Hello everyone and welcome to Thursday's maths lesson. For today you're going to need to have a pencil, a piece of scrap paper for the introduction, and the worksheets will be uploaded onto Dojo. So today we're going to be thinking about standard partitioning, and you will see pictorial representations of deans which you're really familiar in using in class for our concrete resources. So the aim of today's lesson is to compose and partition 4-digit numbers using standard partitioning. The success criteria is that you can identify the place value of each digit in a 4-digit number. You will be able to combine units of ones, tens, hundreds and thousands to compose 4-digit numbers. You will be able to partition 4-digit numbers into standard units of ones, tens, hundreds and thousands and write the related addition calculation. And you will also be able to solve problems relating to the subtraction of any similar value part from the whole number. So a recap on things we've learnt previously in class to do with 3-digit numbers, and 3-digit numbers are numbers that use the place value positions of hundreds, tens and ones, as you can see from the pictorial representation of the deans on a place value grid. So your first task, if you have your pencil and piece of scrap paper ready, is to write down the value of the underlined digit in each of these 3-digit numbers. So the first one is done for you. So we've got here 467. The number 6 is underlined. The 6 is in the tens place if you were thinking about it on a place value grid. So we know that 6 tens have the value of 60. So the underlined digit 6 has the value 60. So let's have a look at the next number, which has the number 5 underlined. So if you have a go and write down what you think the value of that is. So if I was writing that on a place value grid or using deans to represent it, the 5 would represent 500. Let's have a look at the next number with the digit 8 underlined. If I was writing out that 3-digit number or representing it using deans on a place value grid, the 8 would be in the ones place, so it's worth 8 ones, its value is 8. And the final number is 963, and the 9 is underlined. The value of 9 is 900 if you had that in the place value grid, or we're using deans to represent it, the 9 has the value 900. So when we're moving on to 4-digit numbers, we can still use our place value grid and our deans as representation, and you're familiar of seeing what 1,000's deans cubes look like. So 4-digit numbers are numbers that use the place value positions of thousands, hundreds, tens and ones. You can see here it's represented using numbers instead of deans, but still using that place value chart to help you. And you know that you can have a TH above the thousands, an H above the hundreds, a T above the tens, and an O above the ones to help you. As you can see here, they've represented the number using counters. If you think about our working wall in class, we have a place value grid exactly like this using counters to represent a 4-digit number. So can you say this 4-digit number? The 2 represents 2,000, the value is 2,000. The 6 represents 600, the value is 600. The tens are represented by a 3, so the 3 represents 3 tens and the value is 30, and the 4 represents 4 ones, the value is 4. So have a go at this one. So complete the sentence stem for each digit in this 4-digit number. So the blank represents how many thousands and the value is. The 4 represents 4,000 and the value is 4,000. Moving on to look at the hundreds place. So the 1 represents 100 and the value is 100. Moving across now to the tens place. The 5 represents 5 tens, therefore the value is 50. and finally to the digit with the smallest value. The 3 represents 3 ones and the value is 3. You can have a go using your scrap piece of paper to write down your own 4-digit number and practice saying and writing down the value of each digit. If you had a dice at home or some kind of digital way of rolling something 4 times, then you could work out some numbers and have a go yourself. You'll be familiar of looking at a part-part-whole model. So in this part-part-whole model, the individual units of a number are shown, and you need to combine them together to compose the 4-digit number. It's made up of 3,000, 400s, and 10, and 2 ones. So the final number is 3,412. What 4-digit number do you think these unit parts combine together to make? Have a go on your scrap piece of paper. First of all, look at the value of the thousands, then look at the value of the hundreds, and then the tens, and then the ones, and you can put those together and write the number in the whole of the part-part-whole model. 5,325. This part-part-whole model is interesting. It's quite tricky because one of them does not have anything in at all. We need to remember that you cannot just leave that blank. You need to remember your 0 as your placeholder. Let's have a look at this one. 1,500. We don't have any tens, but you still need to remember to put that 0, otherwise you'll be working with a 3-digit number, not a 4-digit number. And 1. So it's 1,501. This time they've given us the whole number and we need to partition it. 7,363. If you need to draw thousands, hundreds, tens and ones above a number to help you, that's a really good way. It's made up of 7 thousands, 3 hundreds, 6 tens, 60, and 3 ones, 3. What individual parts does this 4-digit number partition into? Have a go on a scrap piece of paper. Six thousand, 5 hundreds, 2 tens representing 20, and 4 ones for 4. Here is another number that you can have a go at also. This one has 2 zeros as placeholders. So we have 5,000. We don't have any hundreds at all in this number. We have 7 tens or 70, and there are no ones. 5,070. Remember, like I said, if you need to draw the thousands, hundreds, tens and ones above the number to help you, that's a good method. Look carefully at how Mira has combined the individual unit parts to compose a 4-digit number. Is she correct, and explain your reasoning? Mira is saying these unit parts combine to make the 4-digit number 6,283. Have a look. Is she correct? Is there 6,000 there? Let's have a look. Although the order of the unit parts doesn't go from thousands, hundreds, tens and ones, they're a bit muddled, it is not correct because the 60 is first. It's not in the right place. If you have 3,268 is the correct answer. Let's have a look at how Mira has used the part-whole model to solve this word problem. Is she correct? And explain your reasoning. A football stadium can hold 5,735 people. So far, 700 tickets have been sold for the match. How many tickets are left? Mira says, well, I know 5,735 take away 700 is 5,035. So there are 5,035 tickets left. Mira is correct. She's used the part-whole method to subtract a unit part. That's a really good method. And remember, something has been sold. We're thinking about how many things have been left. So it is a takeaway subtraction number sentence. The sheets have been uploaded to Class Dojo. You can start with the first one, work your way through. If you're finding them easy at the beginning, feel free to skip through. Good luck.